Okay, here we are with the last section of Math 135. Congrats, you have made it. Awesome. Too bad I can't shake you all by the hand. All right, so we're looking at logarithmic scales. Okay, so applications of logarithms. So there are three different main applications we're going to be looking at in this lecture. So first one is the pH scale. So it's measuring the acidity of a solution, which is defined by the equation pH equals the negative log of h to the plus power. So where h to the plus power is the concentration of hydrogen ions measured in moles per liter m. All right. Okay, not as bad as it sounds. All right, so classification of the acidity of a substance. So this is the definition, the sort of the threshold that we have set as what's considered acidic, neutral, or basic. Okay, so if the pH value you find is less than 7, it's considered acidic. If the pH value is equal to 7, it's a neutral. And if it's greater than 7, it's considered basic. Okay, so let's go ahead and do some word problems on this. So a substance has a hydrogen ion concentration of h to the plus power of 2.7 times 10 to the negative 8 m moles. Find pH, so find the pH, and classify. Okay, so we're going to find the pH value and then classify whether it's acidic, neutral, or basic. All right, so we know P of H equals negative log H. Okay, so we are given this value right there. Oh, not the M, sorry. So let's plug that in and get this is careful. So it's a lowercase p and a capital H. All right, so I will be watching for that. Make sure you write these correctly. Okay, it's 2.7 times 10 to the, what was that, negative 8. And we're going to go ahead and just plop this into our calculator because we have one. All right, so let's see how we do this. Okay, so remember we want the negative key. Oops, the negative key, not the minus. So not that one, we want the negative key. So negative log 2.7, multiplication symbol. Remember that's a multiplication, not an x. 10 to the negative 8 power. And then close parenthesis. What do we get? Aha, 7.56. All right, it doesn't tell me where to round to, so I'm just going to round to 2 decimal places. That's just my default. So it's approximately 7.57. All right, so remember it's a word problem, so we have a sentence. So the pH is approximately, actually that is approximately 7.56, which is greater than 7. So substance is, which one is it? Basic. All right. Example 2. So if the pH reading of a brand of beer is 4.8, find the hydrogen ion concentration. All right, so this time we're given the pH and we're asked to find the hydrogen ion concentration, H+. All right, so what do we have? Well, we know that P of H is equal to negative log H+, or the hydrogen ion concentration. So what I'm going to do is change this into exponential notation. So it's going to be 10 to the pH is equal to log H. Oh, before I do that, sorry, I'm going to multiply both sides by -1 to move that negative to the pH. Okay. So that's going to be 10 to the negative pH equals H positive. All right, so what was the pH I was given? The pH I was given was 4.8, so we're going to go ahead and replace that pH with 4.8. That'd be 10 to the negative 4.8. Okay, plugging that into our calculator, that's going to be 10 to the negative 4.8, which is 1.58, blah, blah, blah. So H plus is approximately 1.58. As usual, unless I was told otherwise, I just rounded 2 decimal places. So the answer is the hydrogen ion concentration is about 1.58. All right, so that was the pH scale. The next thing we're going to look at is the Richter scale. Okay, things we hear about a lot in Hawaii. All right, there's always some earthquake somewhere that's going to cause a tsunami someday. Okay, so the Richter scale, the measures the intensity of earthquake. All right, I feel like that was a typo on my part. All right, so M equals, this is the equation we're given, log of I over S, where I is the intensity of the earthquake, which is multiplied by the amplitude on a seismograph, that little thing that goes, and the reading taken 100 kilometers from the epicenter of the earthquake. And S is the intensity of a standard earthquake, okay? The amplitude is 1 micron, or 10 to the negative 4 centimeters. Okay, and the magnitude of a standard earthquake is M equals log S over S, which is log 1, which equals 0. All right, lots of information. Okay, let's get to an example. So, find the magnitude of an earthquake that has an intensity of 4.75. That is, the amplitude of the seismograph is 4.75 centimeters. All right, well, using our formula, M equals log I over S. Okay, so we know that S is 10 to the negative 4, okay, from our definition up here. And then our given intensity is 4.75. Okay. So this is my S value, and this is my I value. Okay, so plugging those in, it's going to be log of 4.75 all over 10 to the negative 4. Simplifying that, that's going to be log of 47500. So 47,500. Plugging that into our calculator. Or you could have just plugged this other value in, but simplifying if you can. So that's going to be log of 475 null equals 4.67. We're not told how to round, so we'll just go with 4.68. Why not? Okay, if you're not told how to round, I just normally round to 2 decimal places. So the magnitude was about 4.67. All right, one more to go for this, and then we have one last way of using logarithms. So an earthquake was measured to have a magnitude of 6.2 on the Richter scale. Find the intensity of the earthquake. Okay, so this time, instead of being given I, we're given M. So we're going to use our equation, I over S. We're given that M is 6.2. We know that S is 10 to the negative 4, and we're going to find I this time. All right, let's go ahead and first let's solve for I. So solve for I. Okay, so to get it out of the argument, I'm going to go ahead and turn it to exponential form. So that's base 10. It's going to be 10 to the m power equals log I over S. Oh, not log, I'm sorry, we've just taken it out of logarithms. 10 to the m is going to equal I over S. Okay, multiplying both sides by S, get I by itself. We get S 10 to the m power equals I. Okay, so subbing in our values here, we have M is 6.2, and then S is 10 to the negative 4. right. Let's plug that into the calculator. Actually, you know what? These have the same base, so I can simplify that. That's going to be 10 to the 2.2 equals I. And then now I'll plug that into my calculator and see what my answer is. So 10 to the negative 2.2 equals. Oh, that's supposed to be a positive 2.2. I'm sorry. That looked strange. All right, 10 to the positive 2.2. Enter. 158.48. And I can round that one up to 158.49. So I is approximately 158.49. So the intensity of the earthquake is about 158.5, which means the amplitude of the seismograph it's an S, not a Z. Seismograph reading is about 158.5 centimeters. Ooh, that got crooked. Okay, so there we go. There's our answer. And one last example, and that is it for 135, and then it's just time to review everything we've gone over. All right, the decibel scale. So the measure of loudness of sounds. So the decimal level B, measured in decibels, dB. Notice that's a lowercase d and a capital B. Okay, so be careful when you're writing things. Is defined as B equals 10 log I over I sub 0. Okay, so we take as a reference of intensity that I sub 0 is 10 to the negative 12 watts per square meter at a frequency of 1,000 hertz, which means that a sound is just barely audible. Okay, and then the decibel level of the barely audible reference sound is B equals 10 log I sub 0 over I sub 0 equals 10 log of 1, which is 0 decibels. All right, lots of wordage. Example 4. So find the decibel level of a jet engine at takeoff if the intensity measured was at 100 watts per meter squared. Okay, so this time we are given the intensity, okay, and we're trying to find B. Okay, so B, note by our equation, is log I over I sub 0. Okay, well, we know that I sub 0 is 10 to the negative 12, and we know that intensity is 100. Okay, so that's going to be 10 log of 100 over 10 to the negative 12. I'm going to go ahead and simplify 100 to 10 squared. Okay, and then I'm going to go ahead and combine these two using the quotient rule for exponents. So it's going to be 10 log 10 to the 14. Okay, so simplifying that is going to equal, okay, I'll bring out my, that's going to be 10. Okay, this is 10, log is 10 of 10 to the 14th power. So these guys can cancel each other out, and we're just left with 14. That's times 10. So 14 times 10, which equals 140. All right, so our answer is the decibel level is 140 decibels. Lowercase d and capital B. All right, so the intensity level of a motorcycle engine at full throttle, find the intensity level of a motorcycle engine at full throttle if the decibel level was measured at 80 dB. Okay, so this time we're given we're given decibel and asked to find the intensity. So switched. So same idea, we're going to solve for I. because that's what we're trying to find is the intensity. All right, so B, at the moment our equation is solved for B. So let's solve it for I. Okay, divide both sides by 10. Trying to get that log by itself first, or at least with a positive 1 coefficient up front. Okay, and then once I do that, I'm going to split this using that subtraction rule for logs. Okay, trying to solve for I. All right, so now what I'm going to go ahead and do is plug in my values for I sub 0 and B. So I sub 0, we already know, is 10 to the negative 12. And B is going to be 80. This is going to be 80 over 10 equals log base I. Well, I might have plugged this in a wee bit soon, but it'll still work out just fine. So that's 10 to the negative 12. All right, 80 over 10, I can simplify that to 8, equals log base I. Sorry, log of I, not log base I. Minus, now that's a base 10, so they're going to cancel out, and I'll be left with negative 12. But we're taking the negative of negative 12, which is going to be positive 12. Okay, we can subtract 12 from both sides. And we're left with negative 4 equals log I. So solving for I, it's in the argument, so I'm going to turn this into exponential form. So this is going to be 10 to the negative 4th power equals I. All right, there we go, the intensity level. So thus, the intensity is 10 to the negative 4 watts per meter squared. All right, so just like last time, or on the other problems, normally you're given one of the values and you have to solve for either B or I. All right, and that is it for 4.7. Okay, so you have a written homework due by the end of the week. Please email me if you have any questions.